we're talking about measurements and all of that good stuff. Okay, when we are talking about science, thinking about science, okay, there are different types of numbers, okay, and I want us to have a vocabulary understanding in order to talk about them more specifically, okay? Dang it, the slides are not ready. This is embarrassing. Insert animation by paragraph. Next one. I thought I did this. I do this for all my slides, but apparently not these ones. Aha! Okay, so we all know what a number is, yes? Okay. Okay, so the symbol to write a number is called a numeral. Okay, you don't necessarily need to write this stuff down, okay? But one thing that I want us to keep in mind, if I just write a number, it doesn't necessarily have any physical meaning, okay? So if I just write down this, okay, is this a physical object or a physical material?
It's not real.
It's real, but it's abstract, it's conceptual. Okay, now, I mean, this mark on the board is a physical, like, thing, but 7 is more of an idea than a physical thing, okay? Well, what if I make it really big? It's still kind of just an idea, okay? Now, if I had 7 pencils, those pencils are physical objects, but the 7-ness of them, I don't know, it's more of a concept, okay? But obviously we use numbers in science, and science has to do with physical things, okay? And so in order to make something physical, we have to have a unit, okay? And we've kind of already talked about this, how a unit is an amount, okay? And it defines what one of something is, right? So if we're talking about mass or volume or something like that, we have to define how much is one mass. Well, how about gram? 1 gram, okay? And then we all agree that this amount is a gram, and we write it down, and all the scientists just share the same units, okay? So this is how we make numbers physical, so to speak, when we're measuring something, okay? I've seen other teachers, if you think of it like Spanish, a unit is like un it, like what one, right? That's Spanish or French for one, right? Or like for a, like 1 it. Okay, how much is an it? Well, the unit tells you that, okay? And so we have, I'm sure we know examples of units, right? Grams, meters, milliliters, Kelvin, all that good stuff, okay? Now, when I measure something, I need 2 parts. I need a number and a unit, okay? And so because we have a number and a unit, I want to call it by a different name so that we can be clear on what we're talking about, okay? We can call it a quantity, or we can call it a measurement, okay? This might seem kind of trivial, but when we apply this, it'll make more sense, okay? So if I'm going to measure something, it's like, oh, last night in my yard, I saw this really huge snake. It was like huge. And everyone might be like, whoa, how big was it? And I say, it was 8.
Astronomical units.
Right, yeah, 8 astronomical units, 8 meters, 8 inches, right? I obviously need a unit. Okay. Is that a big snake? Yeah, it's a huge snake, okay? As opposed to, maybe any snake is too big of a snake for some of us, but okay. But, right, so this is the number, yes? This is the unit. This is the quantity, okay, or the measurement, okay? So I just want to introduce this concept of a measurement or a quantity has a number and a unit, okay? We okay with that? Questions? Okay, I just want to give words to what we're talking about, okay? So now let me skip over to these slides, and I'm actually going to skip a few slides, okay? So when we have a measurement, it needs 2 parts. It has a number and a unit. Okay, measurements or quantities are not the same thing as a number. Okay, now the reason I'm emphasizing this is because the way you write a number is not always important, right? So for example, if I have this and this and this in math class, are those the same or different? They're the same. They're the same number. In the world of science, if this is a measurement where I measured something, those are actually different. Okay? And to you, by the end of today and the next few days as we practice this, I want you to be able to look at that, and if these are measurements, the way it's written tells you something about how the measurement was taken. Okay? Maybe what type of glassware you used, something like that. Okay? So let's talk about how this works. Okay? I'm gonna skip this little game. Okay, so for example, okay, if I were to say measure a pencil, okay, and I don't have any units here, let's do, I don't know, should we do, let's do centimeters. That's a really short pencil.
Units.
Well, I don't know, units, yeah, whatever, just pick a unit, okay? So for example, if I have a pencil, okay, is this a very precise measurement or not very precise measurement?
Not very precise.
Not very precise. Okay, we got 0, 1, 2. It's somewhere between 1 and 2. Okay, could we estimate? Like one decimal place maybe?
Yeah.
What do we think? 1 point?
1 and 3
Seven.
quarters.
7.
Or 7.
I heard two different, right? So now we're debating, right? We're lacking precision here. If I had a more precise instrument, maybe I could get a better measurement. Yes? Something like that. Do we still think 1.6 or 1.7? Maybe?
Yeah.
Okay. What if we got even more precise? So this is by 1.2, 1.4, 1.6, 1.8. What do we think now?
1.7.
Okay, so now that we have a more precise instrument, I can actually be more confident in what I'm writing down. Okay? Were we right?
Yes.
1, 2, 4, 6, 7. Hey, look at that. Okay?
I guess 1.7 the first one.
You're just that good, okay? But if I doubted you here and I said, I think it's 1.6, could you prove me wrong? All right, okay. So this is where it actually matters. So maybe you guessed the right number at the beginning, but if you can't demonstrate it to someone else who maybe doesn't believe you, then your guess is just as good as that guess because we're just estimating, okay? So the way you measure something needs to be communicated by the way you write down the measurement, okay? So the way we round something, okay, is going to matter, okay? And then what if I wanted to guess another decimal place? Think we could estimate another decimal place after that, or do you feel like we've maxed out at one decimal place? Is it dead on the line, or is it a little past or a little before it?
Be maxed.
That's pretty dead on.
Be maxed.
You think it's like right there?
Yeah.
You think it's dead on maybe?
It's pretty dead on.
Looks like it.
1.69.
6, 9 maybe,
No,
okay?
Past the line rather than.
Right, okay, so again, my point is, we get to a point where the certainty we have at which digit to put begins to go away, okay? And so the way we round it matters. Okay, or a similar idea like this, okay? So even though these are all the same and they all fall on this line, okay, what we're gonna do is we're gonna round our measurement to the place value that our instrument gives us. Okay, so maybe this is exactly, okay, this is different now. So this is 2. Okay, this is also 2, and this is also 2, right? 0, 1, 2, 0, 1, 2, 0, 1, 2. Yes? But this is dead on, okay, but the nearest line I have next to it is just 1 or 3, okay? So I'm just gonna leave it at the ones place, okay? But here I can measure 1/10 of a unit, yeah? And I can see that this is dead on and it's not here and it's not here, right? So I can confidently say that it is exactly 2 to 1 decimal place because I have an instrument to prove it. Yeah? Now this, I don't know how long it took me to make this, but I made all of these lines, okay? There's 100 lines here. Okay, copy paste was helpful
Go
for
to the
this.
second one.
Not only can I say that this is 2.0, but if I were to zoom in, it is not 2.01, because there's a line there, and it's not 1.99, because I have lines to see, hypothetically, right, if I could zoom in. So I can confidently say that that is exactly 2.00 units, whatever we're using here. Yeah?
Yeah.
So are we starting to see how the way I'm rounding is communicating something about the instrument that I actually used? And it's communicating how confident I am and how exact or inexact I measured whatever I measured. Are we kind of seeing that? Okay. So that introduces us to this idea of significant digits. Okay, you may have heard significant figures. I call them significant digits. Okay, so how do we communicate our measurement? Okay, we could write, I used a ruler that went to the hundredths place, right? I used a scale that measured grams to 3 decimal. Like, you could say that, but there's actually a more efficient way to communicate it, okay? And the way we're gonna do that is with significant digits, AKA the way you write the number, okay? So there are rules, or there's a standard way that all scientists worldwide, as far as I know, have agreed to write the numbers so that it very efficiently communicates the level of exactness in their measurement, okay? So since we're in a science class, I'm gonna teach you the rules that all these scientists have agreed to. Cool? Okay, we ready for this?
Yes.
Yes, one person is ready. Okay, here we go. Okay, so here's the rules that we're gonna do, okay? Now, if I make a measurement, okay, so like if I have a scale and I put something on the scale, okay? If I have a digit in my measurement that is not 0, then we say it is significant, okay? Now, I need to define what I mean by significant. I'll let you write that down and then I'll tell you what I mean by significant. We're all important, aren't we? Yeah. Some more than it. No, I'm kidding, sorry. What I mean by significant in this context is it was measured. I actually measured that digit. As opposed to a digit that is just a placeholder to make my number the number I want it to be, okay? I'll show you examples of all this, but we're just building it up, okay? So if I put something on the scale and there's a 5 and a 2 and a 6, obviously that's part of my measurement because it wouldn't be there if it wasn't part of what I'm weighing, right? Okay, now the thing is that some digits, specifically zeros, can be not significant, okay? So if I have a 0 in my measurement, sometimes it's because I actually measured that place value and I know it's 0 right here. Sometimes a 0 is just a placeholder so the other numbers are in the right value, right? The tens place or the hundreds place or whatever, okay? So non-zeros are always significant. It wouldn't be there if it wasn't part of the measurement. But zeros could go either way, okay? There's 3 types of zeros that we need to talk about, okay? If I have something called a leading 0, those are never significant, okay? And by leading 0, I mean a 0 that comes before my non-zero, okay? So this would be a leading 0. That 0 is there just to put the 6 in the right spot. Okay, I didn't actually measure, that's not giving me more precision. Okay, or like if I put another 0 here, right? That doesn't make it more precise. It's still 0.6, right? So those are just there as placeholders. They're not significant. They're not part of what I measured, okay? This is also true if they're behind the decimal place. okay? All of these zeros are not significant.
What do we do with them?
They're important, they need to be there. I'm just saying it was not part of your measurement. So like, let's say I had a cheap scale and I weighed something, so let me change this to grams, right? Here's my $10 scale, I weigh something, it's 0.00018 grams, which is actually like really precise, okay? But let's say I get a really expensive fancy scale, okay? This is $1,000 scale, and I weigh the same object and it comes out, okay? It would still do that, right? I wouldn't have, like if I had a fancier scale, it wouldn't put more zeros out here really. That doesn't make any sense, right? So I'm not gaining or losing any precision by having zeros in front, okay? The only reason they're there is to make the 1 and the 8 be in the right place value that they need to be, okay? So leading zeros are not important for what I measure. It doesn't communicate any exactness in my measurement, yes? Now, if I have a zero that's in between non-zeros, that's called a captive zero. Those are always significant. Those are always part of the measurement. Okay, so an example of that would be if I had 705 liters. Okay, so whatever device I use to measure 705 liters, it clearly can measure to the ones place, right? I got it down to the 1 liters, okay? So even though this is a 0 here, my device for measuring volume is able to tell me, no, I measured it down to the ones place, and I know that that digit, the tens place, is actually, there should be a 0 there, right? It's not 710, it's not 750, it's, right, we're measuring to this level of precision, okay? So a 0 being in between non-zeros is just part of the measurement, okay? And that works for before and after the decimal place, okay? So if I had, let me do 8.007 centimeters. Those are captive zeros. They're in between non-zeros, and so they're part of the measurement, right? And we can see that I'm measuring to this level of precision, so zeros that come in between these non-zeros are part of that measurement, okay? I know that this should be a 0 here and this should be a 0 here, and I have a fancy enough instrument to tell me that. Yeah? What do you think the other type of 0 is? Can you see the pattern I'm doing? We had leading zeros, we had captive zeros in the middle, and then we have
Caboose zeros.
Caboose zeros. Ending zeros. How about trailing zeros? Whatever you want to call them. Okay. These may or may not be significant depending on the situation. So there's actually 2 sub rules here. Okay, this is going to be potentially the most confusing rule because this is a sometimes. It depends on how you write the number. So this is where the way you write the number is going to communicate something about your measurement, okay? Let me define what I mean by trailing zeros, okay? So right, trailing zeros come after all of my non-zero digits. Yeah? Okay. Trailing zeros come after the non-zero digits, right? These are my non-zeros. My zeros that are after those are called trailing zeros. Yes?
Aren't those to show like what ruler you used?
Sometimes, sometimes not. It depends. Let me explain, okay? Now, so the way we communicate this is by putting a decimal point or not putting a decimal point. It's that simple, okay? So this is not a math thing, this is just a communication thing of how we write things down. If I'm a scientist and I put a decimal point in my measurement, I'm trying to communicate that these zeros are because I had an instrument that could actually measure that. If I don't put a decimal point anywhere, I'm communicating that these were not actually measured. I was measuring to this place value. Okay, but I need these zeros here to make this 800, right? If I just take away the zeros, then it's 8, and it's not what I'm trying to say. I'm trying to say 800, but I measured to the hundredths place. Whatever instrument I had could only measure to the nearest hundred.
So if we did like 800.00, then the point zeros are irrelevant with the other two.
If I do this, all of these are trailing zeros. It does not matter where the decimal point is, it matters, is there a decimal point? If there's a decimal point, this is part of my measurement, this is part of my measurement, this is part of my measurement, this is part of my measurement. So this number communicates that my instrument is so fancy, it can measure to there. Yeah? In math class, that's 800 and that's 800. What's the big difference? This is not math class. And these aren't numbers. They're not numbers. What are they? Measurements. They're quantities. It's a different thing. And because they're measurements, the way you write it is trying to communicate something about the instrument you used. Yeah? Questions? Okay, this is the system that all scientists have agreed to use. And so here we are, learning that system. This also works for scientific notation. Can someone tell me how to write this in scientific notation? Yeah? If I write something in scientific notation, this is never part of your measurement. That's just a placeholder, right? It's just telling you that that's 800, right? So check it out. I have one sig fig, or one significant digit. This is my one significant digit. So you can write it in either way, and the same type of precision is communicated. How would I write this in scientific notation? Basically the same thing, right? 8 times 10 to the whatever. But look at this. If I wanted to communicate the same level of precision, I could do that. Does this still follow the rules here? These are trailing zeros, yes. There is a decimal place or decimal point in the measurement somewhere. So those zeros are significant. So I have 1, 2, 3, 4, 5 significant digits, 1, 2, 3, 4, 5 significant digits. Cool. So it works in both ways of writing numbers. Kind of nice. Yes?
Do you want us to round when we're putting things in scientific notation? Like if we had like 20, like if we're gonna end up with, like if it's gonna be like times 10 to the 30th or something, and we're gonna end up with like 30 decimal points because there's like, each one is like a different number or something, do you want us to just like round it to a certain point?
We will talk about that. It will depend on how you got that number. So whether you measure that in a lab and you measured it to like 30 place values, then you get to flex and be like, yeah, I have 30 place values, and get to write all that out. Or if you got that number from a calculation, the numbers that you started with in the calculation will tell you how to write it at the end. Okay, that's later. Okay, but yeah, we will get there. Okay.
Sometimes you just want to round so that it's not a big ugly number.
Now there's rules for rounding, and I'm gonna grade you on it. Sorry. What?
Yes.
Okay. Is it? I might have to get back with them. Okay, I'll talk to you in a minute. Okay, now this applies to measurements. This does not apply to things that are not measurements. Okay. Another thing that can be called is exact numbers. If I'm counting something, we don't have significant digits, right? How many desks are in this room? 34. So if there's 34 desks in this room, can I count the desks more precisely? That's the same thing. There's 34 desks, there's 34 desks, okay? When it comes to counting things, I use an exact number, and what we say is you get infinite sig figs, right? I could do 34 des or 34.00000. It doesn't matter. Okay. When I'm measuring something, I use significant digits. When I'm counting something, I don't. Yes?
How do you decide how many zeros to use?
It's either based on the instrument that you use, and we'll talk about that. We'll go to the lab and I'll show you how to do that. Or I'll give you measurements and we'll talk about how to do it from there. Yes?
How do you decide what's counting and what's measuring?
Literally, where did you get the number from? Did you physically count something, or did you
Just
measure it?
like decimals of something that you're counting. You'd have like 7.5 chicken strips.
Yes. So then, are you just counting halves, or are you like measuring it by like the weight? So the way you get that number, by either counting the halves or measuring it by like pounds,
So you
that
can-
will tell you
You could
what.
count or measure chicken strips.
Yes. And the way you get the number determines which system we're using. Fair question. It's a funny example, but like it's a
Yeah,
legit question.
Yeah. Gotcha.
Okay. Other questions? Okay, this is gonna confuse people, so I'm gonna try to tell you ahead of time, okay? Leading zeros precede the first non-zero digit, okay? I don't care where the decimal point is, okay? Some people think that only these are the leading zeros because it's in front of the decimal place. That's not what leading means. Leading means it's in front of the non-zero digit, okay? So this is a leading zero, that's a leading zero, that's leading, okay? They are all leading, they are not significant, they're just placeholders. Okay, another thing is that trailing zeros go after the last non-zero digit. I don't care where the decimal point is, I care about where the non-zeros are. Trailing, all of those are trailing zeros. Whether they're in front of or behind the decimal point does not matter. What matters is, where's my last non-zero digit? Okay, so should we try to say that now, and hopefully we won't switch it in our brain later. Okay, their placement relative to the decimal point is irrelevant. Okay, let's practice. Well, let's just go one at a time. How many digits in this measurement are significant? AKA, how many of those digits were measured from my instrument? 3 of them? How do you know?
Because they're significant.
They're non-zero. They're significant because they're non-zeros. So that we would say there's 3 significant digits. Okay? What about this one? How many of those digits are part of what I measured?
3.
How do you know it's 3?
The captive.
Captive 0 is significant. 3 significant digits.
2.
How do you know?
Because
They're the zeros
leading
are
zeros are
four.
not significant.
Okay, so obviously the non-zeros are significant. The question is, are these zeros significant? They are not, because they are leading. 2 significant digits.
Four.
4 question mark? 3 or 4?
3.
It's 1, 2, 3, or 4. Multiple choice. What kind of, obviously these are significant, right?
I think it's 3.
Yeah.
This is never there. That's never significant. It's there. It's not significant, right? It's just a placeholder. What kind of zeros are those?
If they're there, they're gonna
It's
be
trailing,
significant.
but there's a decimal, so they're significant.
There you go. They're trailing. There is a decimal point, so they're part of my measurement. Okay, I'm putting them there to communicate a level of precision. So 4. 3 people think it's 1. Another person thinks it's 1. Trailing zeros, yes. Do I see a decimal point? No. This is what I measured. These are just here as a placeholder to make this be in the 10,000s place. But only one of those digits was part of what my instrument could measure. Okay? Here's a fun one. I'm gonna make them more complicated as we go. There's 1, there's 2. Captive 0 is significant. These are all trailing zeros. There's a decimal point, so all 3 of them. 6, very nice.
Two.
About half the class is talking to me, so half of us get it. Does anyone else have questions on why these are the answers? It's okay to ask questions now. Okay. I have a bunch more. Oh yeah, this is a fun one. This is me trying to make a point. Can you run through and tell me how many sig figs for those?
All of them.
How many here?
4,
4,
5,
4,
4. I can count. Okay. 4, 4, 5. Wait, no.
4,
This one's obviously significant.
4.
Leading 0.
4,
But there's 3 after.
4.
Wait, and there's a decimal.
Good job, Ben.
Just keep saying 4, man.
4.
Always throw it.
4.
Yep, just keep.
These are significant.
5.
Those ones aren't because it's leading.
They're both leading, right? Because they're in front of the 5. I don't care where the decimal point is. They're in front of the 5.
But the decimal makes the other 4.
The decimal makes these significant. Yeah, good.
4,
4. 4.
Okay, now the reason I did this whole thing is to make a point about these leading zeros. Okay, I don't care where the decimal point is, I just care about is there one. Because the decimal point tells me whether these are significant. Cool? 4. Okay. Let's pause there. Let's get Chromebooks. Fast, go, run.
Keep all of the block cabinets.
These big wooden cabinets.
Those ones, okay.
Yeah.
I don't remember which ones you said.
Yep.
So basically, it's always the number behind or between that are relevant.
It's
If there-
not
if
always,
there's a
it's not
decimal.
always behind. Yes, if there's a
If there's a
decimal, right.
And if there's not,
Then
then
it's
you
just
use
the in-betweens.
decimal. I know.
Sorry.
Ben, you missed Tony last night.
I know.
Tony was at class.
My freaking boss made me go working.
Bummer.
I thought about skipping, but I decided that it would not be a good financial decision.
Fair enough. You did the right thing.
I like Tony though. He's probably my favorite.
He's cool.
I talk to him a lot.
Yeah.
He must be in college.
Yeah. Jake was like, Tony, you gotta meet Austin, and so he made him talk. Yeah.
His style's really adaptive to wrestlers.
Cool. Cool. Okay. Don't forget to pause the video.